Hey, what's going on YouTube? How's it going Twitch? We should be live now. What's up? Today is, I think, the last day that we're going to be doing calculus for a while. So, farewell, calculus. We are focusing for the high school math. We're focusing on this other really wonderful yellow book, Basic Mathematics by Serge Lang. So, I'm replacing calculus in the middle school, high school. Well, really, calculus is high school. We're replacing that with this middle school, high school book, this pre-calculus book instead. And so this week I've been treating college. I work 1 week at a time. 1 week of high school math, which we did basic math in, 1 week of college math, and then 1 week of graduate level math. So beginning tomorrow, how was your lunch? Lunch was good, man. My wife gave me her leftovers from yesterday from this Korean place, and it was so good. Hey, Divium, good to see you again. Good to see you. Welcome back. Okay, so farewell calculus. Good riddance. Good riddance, truly. Not really. We want you to study Olympiad style maths. Not anytime soon. I just want to be clear. I want to make sure that we're working systematically, predictably through a few books, so that we know, that we're making proper progress. Someday I would like to do Olympiad math, but not soon. Good to see you, though. Good to see you, dude. How was the rest of your lecture? Did you already finish that video, Leo? Shout outs to Leo in the chat, by the way. Yeah, hope that video was pretty good. I Oh, now verified. Stream.leoalcock.org shows everyone listed is live when live. Dude, that's awesome. I want that so much. I would pay you for that if you charged me. I would, dude, let's just build all the missing live stream features that YouTube is missing. Let's just build those. Let's just vibe code those and make a bunch of money so that we can just study math on the internet, dude. Seriously, there's just so much that's missing. And yeah, just a decent, now live list that doesn't require you to, look at your home feed all the time. I only want to see and check if anybody's live streaming, right? I do not want to get sucked into the algorithmic black hole of video recommendations. We'll put up a Discord bot for it soon, actually. That sounds really dope, dude. Seriously, this is one of these things that's been in the back of my mind. If I ever get around to it and feel like vibe coding, that sounds like a weekend project or a day-long project. I bet Claude could, one-shot that app, and it would be something that I would be willing to pay for. I think a lot of people would be willing to pay for that. Good for you, man, for actually doing it. Okay, so we finally hit one of all the different types of problems from section 1.3. So y'all know there are a few different categories of problems in Taalman and Kohn, which I love. There's the thinking back problems, the concepts problems, the skills problems, applications, proofs, and then thinking forward. So, yesterday, now we have one of every type of problem done from sections 1, 2, and 3. Now, yeah, Beetle. Your name is Beetle. Leo was just reacting. Leo was just watching that video on his stream. By the way, shout outs to Leo. Leo streams. If anybody doesn't already follow, you should follow Leo. For real. I look forward to watching that video someday. I don't know when. But it's, dude, I don't know. Leo, this is a question for you, man. Fermat's last theorem is one of these monumental, beautiful results that has fascinated me, and I want to learn, and I think I could learn it properly someday, right? Doesn't it feel like it's kind of robbing that result from me to not learn it from a textbook? Like I kind of want to take it slow and work the exercises and get the history and work through books to climb that Mount Everest and learn it the slow way, not the like here's the snappy 5 minute high level summary. Like, yeah, I don't know, man. I don't know. I don't think the video's explanations are that good. See, like, here's the thing. I don't trust this person. When I saw that video, I thought it was AI at first. Like, at this point, you don't really know. Like, it could be a deep faked AI video. And I don't really want to learn Fermat's last theorem from a deep fake AI math YouTuber. Like, dude, come on. I mean, he probably isn't, but soon my default reaction is going to be YouTuber is probably AI unless I've met them on Zoom, Again, there's a question of to what degree do you want to know it? Yes. Not aware of a textbook account of FLT. Actually, my friend, Arad, I'll show you. I really want to work through both of these books. As I understand it, these Edwards books are very good at giving the history, like the historical context of Galois theory, how it was invented, and then, like introduction to FLT. This is really introduction to algebraic number theory. This was published, I believe, in the 80s or 70s or something. So obviously this does not go through Andrew Wiles's proof, but it gives the historical context that gets you thinking about the problem, I suppose. Like, this one looks really cool. I've been wanting to work this one for a while. This John guy is never touching this book. Which one? This? Yeah, it would. I don't know. We'll get there someday. Mate, but you're stuck on the Mount Everest of doing the same linear algebra exercises 10 times a day. Funny enough, we've moved on from that. We're not going to be working that linear algebra book anymore. I am actually replacing linear algebra in my college series. I'm replacing it with abstract algebra next. So I'm excited, man. I hope you all are too. Yeah, this book looks really good. And then there's a lot of newer books. There's a bunch of newer books as well, but I want to understand algebraic number theory, in the context of Fermat's last theorem, and like why we understood it to be a very hard problem, and some partial results and things like that before I just jump right to the conclusion or something. Slow and steady, dude. Slow and steady. That's the key, I think. Yeah, I think it looks good. I've read very good things about it. I've read very good things. Now we're doing high school calculus thrice a day. Today's like the last time. And, dude, calculus is college. It's like a good, last class of high school or first class of college. This one counts as college math this week, and we're done with it. Continuity. We're finally moving on to section 4 for the first time. Let me jump all the way down. So now, let's get started. Section 4 on continuity. All right, so I always go straight to the problems. Okay, exercise. I want to do first a thinking back problem first. Thinking back. Number 1. Thinking back. Finding roots of piecewise defined functions. For each function f that follows, find all values f of c for which f of c equals 0. Check your answers by sketching a graph. Okay, so our function is piecewise defined as 4 minus x squared if x is less than 0, and it is defined as x plus 1 if x is greater than or equal to 0. And it asks, find all c such that, find all roots of this function such that f of c is 0, and then sketch the graph. Okay, so solution to this. If f of c equals 0, then c is less than 0 and 4 minus x squared equals 0, or c is greater than or equal to 0 and x plus 1 equals 0. In the first case, c is less than 0 and x squared equals 4 has one solution, which is x equal to -2. In the second case, x plus 1 equals 0 and x is greater than or equal to 0 has no solution, as x plus 1 equals 0 implies x is -1, which is less than 0. So we need both the equation to be true and the condition to be true. So x in this case is not greater than or equal to 0. Thus, exactly one. Do we call 0 points roots even for like piecewise defined functions, or is like the word root somehow limited to polynomials or something? Like, I think that we still call them, there's zeros or roots. There's exactly one 0 of f of x, which is f of -2 This is the only 0 of the function, and the graph, reminding ourselves that our function is defined piecewise as, I believe, 4 minus x squared when x is less than or equal to 0, and x plus 1 when x is greater than 0. Was that correct? 4 minus x squared, x plus 1, yep. So when x is greater than 0, I'll do the second piece first. It's a little easier to see, I think. The y-intercept, like it has a limit point of y equals 1, and we'd have this 45-degree angle. Continues. This is x plus 1 plotted on the right half of the plane. And then on the left half, 4 minus x squared. 1, 2, 3, 4. So when x is -2, y is 0, the function would look something like this. This point is solid, and then this point is an open circle. It's a little hard to see, but here's approximately our piecewise function. Everything working? 0, 1 should be open. What's going on? Hey! Baldwin the Anchorite. I'm happy to hear that you're enjoying the videos and the problems so far. I think that, like, good for you, dude, because the real learning is going to happen with the exercises. It's always going to happen with the exercises, and I think that they're fun. I think Lang's book is really well written and accessible. I don't need to, like, walk through every single exercise and step through, like, everything. Not yet. Like, maybe when things get a little harder, but I'm trying to encourage those who are following that series to actually read the section, because that's how I'm going to help people develop that important thing called mathematical maturity, like the ability to read a book on your own. Okay, let me catch up in chat. So we just finished this one. Heck yeah. I'd call them zeros, but if you said roots, I'd understand what you mean. Yeah, after I said roots, I was like, I think zeros is just a little more accurate somehow. Yeah. And roots are for polynomials. I'm glad I was thinking that. I'm glad I was thinking that, because I was like, I think you reserve roots for polynomials, but then you speak of zeros for other functions. Thanks for confirming, y'all. I just want to get this open circle a little more visible here. Okay, so here we go. This function has exactly 1, 0 at -2. Here's the only 0 of that function. Yeah, we got a bunch of self-studiers in this chat, in this community. That's freaking awesome. That's the goal here, dude. I think so many people are studying math for fun, and it's just underrepresented. So underrepresented. Who are you all talking about? He brings up GCD. Who is he? The person in that video? The FLT video? Yeah, like if that FLT video introduces GCD and begins with like GCD and gets all the way to FLT, this sounds like an amazing video. That sounds awesome, actually. Yeah, TBH, the context of Fermat's last theorem is nearly all of number theory, right? Right. Yeah. FLT motivates so much of number theory, right? That's why I want to learn from a book, that like guides me through all the other stuff, not just FLT and not hand waving. I want to get the whole path there. Yeah, Beetle, like that video is going to move fast, I think. Like if you don't have any number theory background, I would wait. Like you're not going to be able to follow somebody trying to prove FLT. Like watch it enough to motivate you to crack open a number theory book, because you got a lot to learn first. Baldwin, super happy to hear that you're enjoying it. 0, 1 should be open. Yeah, I mean this function is defined on the real numbers. So I think when you said open, you mean like to use an open circle, that it's not included, that point. And that would be true. Oh yeah, 0, 1, yes. Yeah, like the coordinate x equals 0, y equals 1 is open. Yes. I clarified that as we went. Yeah. Good catch. You were right. Congrats, Apex Goblin, for dominating the JEE. That's awesome, dude. Yeah, I'm super curious what it's like for you trying to watch that video, Beetle. And Beetle, if you don't know, Leo just did a video talking about that video that you're watching. So you should definitely watch his stream, his video from earlier today, I think. Leo Lectures is definitely making videos on number theory, I think. No problem learning from this video. Okay, okay. Uh, Erdos unit conjecture recently. Ooh, yeah. Complete playlist with proper Olympiad style problems. Algebraic topology. I want to learn algebraic topology. I never have. Okay, cool. Well, we did the first one. We did a thinking back problem, and this is now setting the stage for something called continuity. And sneak peek, for those who don't know, this function is discontinuous because the limit at 0 from the left does not equal the limit from the right. So at that point, you can find an epsilon delta neighborhood, where you can always, I don't know, find y values that are outside of the neighborhood. The limit is not defined at every point. I think that for a function to be continuous, its limit needs to be defined at every point. So let's start reading. Let's start rereading and learning the section problem 0 under concepts. In this book, there's a nice pattern. They spend so much ink writing this in every single exercise set. Concepts. Problem 0. Read the section and take notes. Every single exercise set reminds you, don't forget to read the section and make your own summary of the material. Problem 0. All right, let's do it. I've learned this before, so I'm going to try to take a high-level approach through this. I'm just going to be reading Section 1.4, continuity and consequences, has 3 main topics. We've got continuity of functions at points and on intervals, and basic types of discontinuities. Continuity at points and intervals, and simple discontinuities. It says basic types of discontinuities. I'll say simple discontinuities. Then secondly, we have simple functions that are continuous on their domains. Simple functions continuous on their domains. And then thirdly, the extreme value theorem and the intermediate value theorem. So this section, we get to extreme value theorem and intermediate value theorem. And I know what most of these words mean. It equals the limit from the wrong. Yeah. The math, actually, the iPad, the right-hand side of the iPad is showing. The way that the iPad shows up, it wouldn't really help that much more. Actually, it wouldn't buy very much more screen real estate. This is already as wide as it as it gets. Otherwise, I would be chopping. I'm already chopping off some stuff at the bottom of the screen. Oh, well, actually not as much as I thought. But yeah, we're more bound by the height of the iPad than we're more bound by the height of the iPad than the width. I suppose maybe I could take back some more from the top, but anyways, I played around with it a lot and I found that this is a decently good aspect ratio. Why'd I put my streams on members only? It's because people keep watching the stream and then unsubscribing. People don't realize that the streams are not meant to be rewatched. Like, the streams are actually literally meant for the people who are there live. Like, if you want to watch the streams afterward, that's awesome, but I kept getting comments from people that say, dude, you're spamming us. Like, dude, like, chill out. Why are you doing so many different subjects? It's like, no, actually, like, this is my own study sessions over like a year. Like, I didn't just film these and I didn't just post these. Yeah. So, I mean, there's that, and then it's a way that y'all can help support what I'm doing, obviously. What I've landed on is I'm thinking that the most recent week of live streams for any subject is free. And so there will always be 5-ish videos for every subject. And then you can check those out. But if you want to go back and watch hundreds of videos, I think it's worth the lowest tier. I mean, the Luna level membership is $1 US per month. It's the lowest price that I can set, or 59 rupees. Like, it's not very much. I'm sorry. Hey, thank you for somebody for the 550 jewels, bro. Thank you, Luke. Thank you, Luke, so much. Let me put you on the thanks page for that, bro. Appreciate you, and I'm going to give you credit in this math exercise set, bro. I appreciate. Should I write the whole name? That's a long name, dude. Luke, let me know if you want something else, but Luke, I'm just gonna go Luke Downs. It looks like you wrote that a few times. Luke Downs, 5900. If you want, I could add the 5900 if you find that important. Bro, appreciate you. No need. I have no idea what it is. This is just my thanks page. Thanks to everybody who's a channel member or anybody who's ever tipped anything. Like, thank you for, your support. I appreciate you all. And I will also put you right in here. Where is it? Exercise set. Thank you for supporting calculus. Luke Downs. All right, dude. You're right at the bottom of my textbook on that page. I'm doing well. What's up, Technical Sudeep? How are you? Appreciate you. Thank you. And I will hydrate. Absolutely. Beetle, you've never seen a good math teacher IRL. That sucks. Not gonna lie, I saw you connections and assumptions video yesterday. Well, baked AF, and it was actually good. How you weren't forcing us a single perspective answer, but we looked at math from an overview. Hell yeah, dude. Hell yeah. I don't know, connections and assumptions video. There's a lot that could describe, but I'm happy to hear it. Because, math really is an offshoot of philosophy. There's There is a lot to math. Like, it is not just like a black and white, this is the one true math, this is the one true way or something. There are, like, you need to understand what your assumptions are and agree on the same assumptions, and then you can agree on results. But different people describe different, start from different assumptions. You skim over mathematical exercise on streams. Yep, I stream almost every weekday. Why didn't you do an MSc or PhD in math and then research? I was going to, but then I wanted to make money instead. I felt like I wasn't good enough to become a math researcher. I love it very much, but it's a hard path. It's a hard job. Instead, I did my math bachelor's degree, and then I worked as an iOS software engineer at Apple. Here, I'm going to do it this way. Apple, Lyft, and Google as a software engineer. Then my entire team got hit by layoffs shortly after ChatGPT came out. So ever since, I've been an independent entrepreneur, creator, person. Like a YouTuber, creator. And next, I want to become a freaking school teacher. I want to teach the little children. That's the next goal. So, thank you all for helping me on this amazing journey. Appreciate you all. Yeah. Goal is to become a school teacher. Calc 3 is vector calc. Yeah. Hey, Locke. Good to see you, dude. All right. So, but I want to continue also at the same time. Dude, you can just study math as a hobby. Like, I want to learn PhD level math and maybe even do research someday. Like, as a hobby, you can do that. It's not impossible. It's not impossible. Okay, so now I know what the topics are going to be in this section. Yeah, you'll hate on Calc 3 because it's got vectors. Locke does not like vectors at all. Does not a fan. Okay, intuitively, a function is continuous if its graph has no breaks, jumps, or holes. Okay, intuitively, continuous means no jumps. If its graph has no breaks, jumps, or holes. Oh yeah, no jumps, breaks, or holes. Okay, so I misspoke earlier. Because earlier I said, I misspoke because I said that the limit from the left needs to equal the limit from the right. But it also needs to equal the function value at that point. So, for example, the graph of 1 over x has a hole at 0. This function is discontinuous because it doesn't have a value at that point. So, like, an intuitive explanation is that a graph is continuous if you can draw it without lifting your pencil at all. Like, you can draw the thing and it's not, that is not the graph of 1 over x. I was thinking that. I was like, wait a minute, that's not right. I was thinking, that doesn't sound right. Yeah, 1 over x, my bad. Oops. Lol. No, I meant x squared over x. Yeah. My bad. Thank you, Locke. I blanked for a second. this thing is similar to y equals x, but it's discontinuous at the point x equals 0. That's an amazing graph of 1 over x. I know, yeah. I need some more coffee. He just likes unemployment, I know, right? He likes doing PhD research as a hobby. That's the goal. That would be awesome. If I could, I would. That sounds freaking fun. I mean, I have no progress at all toward contributing research, but that would be fun in theory. I would like to do that. I would like to try. Loosely speaking, you can sketch the graph of a continuous function without picking up your pencil. If you can draw the graph without picking up your pencil, we can make it more precise by using limits. Consider these graphs. While the first has no breaks or holes, the remaining 3 all have some sort of bad behavior. And the examples that they give are y equals, well, yeah, it doesn't say exactly what the f of x is, but it looks like y equals x. This next graph they draw piecewise, and it's a graph that looks like this. Then the third graph is one that looks like this. And then the fourth one is a graph that looks like this. So all of these have a bad behavior, quote unquote. There's a hole, there's a jump, and other things. It turns out that limits as x tend to 1 detect exactly this bad behavior. In each case, the limit as x approaches 1 is not the same as the value at x equal 1. For example, these functions are f of x, g of x, h of x. They're labeled these, h of x and k of x. So g of x, let's see. Limit as x tends to 1, g of x does not exist, but g of 1 equals 2. The limit of h of x equals 1, but h of 1 equals 2. And limit of k of x equals 1, but k of 1 does not exist, is undefined. So whereas for f, the limit equals the function value. So these motivate this definition. Definition 1.12. Yeah. Next week we will be back to representation theory for our streams, but I will be uploading 2 videos for the basic math series. And in basic math, we will be moving on to section 1.4 on multiplication. 1.3 on multiplication, I believe. Yeah. I do not have children, if you're asking me. Ooh, hey, thank you. Huge 0701, I appreciate you very much. If you don't mind, I would like to write you in my thanks page, dude. I appreciate you. Huge. Oh, wait, no. Two U's, not two G's. Don't know if they're even in the stream or if they just became a member for the videos, for the VODs. But thank you, bro. Appreciate you very much. This is kind of a little speed bump to do this every time, but it's worth it, I think. P2 is definitely a cool plane. I don't know what that is. Ah, I did it again. It should be two U's, not two G's. Okay, whatever. Two U's, G, and one G. Okay, I'm going to scratch out that name. Try it again. E-U-U-G 0701. Thank you, bro. Definition 1-2. Continuity of a function at a point. Says a function f is continuous at x if the limit at x equals c, at a point c, if the limit value at c equals the function value at c. So here is our definition of continuity at a point. Cool. That's what I remember. By considering one-sided limits, we can get a more detailed picture of continuity. Right continuous at x equal 1, but not left continuous. So definition 1.13, left and right continuity a function f is left continuous if the limit value from the left equals the function value at that point and is right continuous similarly. Same thing. Okay. Sometimes convenient to talk about continuity of a function on an interval. So definition 114. We have continuity of a function on an interval. A function f is continuous on an interval I. Function f is continuous on an interval I if it is continuous at every point in the interval of I right continuous at any closed left endpoint, and left continuous at any closed right endpoint. So there's 3 points. Continuous at every point in I in the interior of I. It says interior of I. Right continuous at any closed left endpoint of I, and similarly left continuous at any closed right endpoint. Okay. Let me read chat. You can have a... I never understood the point of left/right continuous. Thought the whole point of introducing continuity was avoiding jumps. I think here's part of it. I think that we want to... You can define continuity to, like, on an interval. Like, it requires right continuity and left continuity. I suppose that this is where, You can have one-sided continuity when the function isn't defined past that value. Also, jump discontinuities are probably the most well-behaved sort of discontinuity, so it's nice to get a good handle on them. So, yeah, if you define a jump, like this function is continuous on 0 to 1, and continuous on 1 to 2 or something, or 1 to infinity, but it's not continuous on 0 to 2, right? Like, this discontinuity is a well-behaved, like one of the most well-behaved discontinuities, I think is what Arad is saying here. Yeah. There's another section that says types of discontinuities. There's a removable. Yeah, when a function is not continuous at a point x equals c, we say that it is discontinuous at x equals c. So, not continuous at c, we say that it is discontinuous. That's just a definition. Discontinuous at C. 3 most basic types are a removable discontinuity. And the example that the book gives is this with a hole here and a filled in point here or something. a jump discontinuity, blah. A jump discontinuity and then an infinite discontinuity. Intuitively, we say that a discontinuity is removable if we could remove it just by changing one function value. If we can remove it by changing just one function value. Interesting. At a jump discontinuity, the function jumps from one value to another, and at an infinite discontinuity, the function has a vertical asymptote. Okay, so as these look, these types of discontinuities can be described precisely in terms of limits as follows. So if you were ever asked to write down a formal definition of those types of discontinuities, this is how you would do it. Removable, jump, and infinite disconts. Suppose f discontinuous at x equals c. We say x equals c is a option 1 removable discontinuity. If the limit exists but is not equal to f of c. Secondly, the second option is a jump discontinuity. Jump, that's a horrible looking jump. My handwriting is getting worse by the day. Jump discontinuity. If the limit from the left and the limit from the right exist but are not equal. So here's a point where this answers Locke's question earlier of one of the reasons you would want to define limit from the left versus right so that we can classify that type of discontinuity as a jump discontinuity. And then we have infinite discontinuity. If one or both is infinite. Now we have our formal definition classifying these simple discontinuities. And we can write it down very precisely using the language of left and right-sided limits. One-sided continuity, not one-sided limits. Oh, I see. Yeah, I don't know. I don't remember. Like, as I'm writing all this stuff down, I'm like, I vaguely remember this, but it's been a long time. I don't remember examples where knowing that it's continuous on either side is useful or not. I don't know. Yeah. I don't know. I don't remember analysis. I think it's useful for trivia mostly. Continuity of very basic functions. So this is an entire section. I'm just going to trust the textbook author here. Continuity of very basic functions. We say that a function is continuous on its domain if it is continuous on every interval on which it is defined. Continuous on its domain is defined here. The following theorem proves that, unsurprisingly, our simplest examples of functions are continuous on their domains. Okay? We have a theorem, finally. Theorem 1.16 says continuity of simple functions. Continuity of simple functions. Constant, identity, and linear functions are continuous everywhere. Constant, identity, and linear functions are continuous everywhere. In terms of limits, we write out all of the things. Power functions are continuous on their domains. Here we go. Now this is a more powerful statement. Power functions are continuous on their domains. In terms of limits, if A is real and K is rational, then for all values x equals c, at which x to the k is defined, we have power functions. In terms of limits, if A is real and K is rational, then for all values x equals c, at which x to the k is defined, we have limit as x tends to c of ax to the kth power is ac to the kth power. Okay. So part B gets us all the polynomials. Does that also get you... I don't think you can write x squared over x as a power function. That's not a power function, right? That's a rational function. It's a ratio of two power functions, right? So we get things like square root of x and others. In probability theory, cumulative distribution functions are specifically right continuous, and that's important for keeping track of atoms in the probability measure. What? That sounds cool. Neat. Almost all functions are discontinuous. That's some crazy talk. That is, yeah. It's amazing that we have these kinds of facts. The real numbers are very strange, aren't they? They really are. I am... In part B of the theorem, the limit may sometimes be only one-sided. For example, f of x equals square root of x is defined at x equals 0 and to the right of x equals 0, but not for x less than 0. Therefore, the corresponding limit statement is one-sided. Okay. Although it seems graphically obvious that the simple types of functions described in this theorem are continuous everywhere they're defined, to actually prove continuity, we need to appeal to the definition of limit. We will prove part A here and discuss the proof of part B after we learn about limit rules in the next section. You will prove that f of x equals x to the k is continuous on its domain for k equal 2, 3, -1, -2, 1/2, and -1/2 in exercises 89 to 92. Nice. Okay, and then there's a proof. I'm going to skip the proof for today because we are moving on from calculus. Haha. Extreme and intermediate values of continuous functions. We examined two important consequences of continuity. A continuous function on a closed interval must be bounded and attain its upper and lower bounds. Okay. Second, if f is continuous between two values, then the corresponding values of x go through every possible intermediate value between the y values f of a and f of b. I remember these. Both of these are results of them having unbroken graphs. Consider a function. I think I followed that. Yeah. Let's write these. Theorem 1.17. The extreme value theorem. Okay. If f is continuous on a closed interval a to b, then there exist values, capital M, there exist values and lowercase m in the interval such that f of capital M is the maximum value of f of x on the interval, and f of lowercase m is the minimum value of f of x on the interval. Okay, the extreme value theorem. So on a closed interval, a continuous function attains its minimum and maximum values. That makes sense to me because it doesn't shoot off to infinity. And it because it's on a closed interval, it's not like it's infinitely getting closer to some suprema value that it never attains. I think this makes sense. Yeah, I was thinking, I do remember this stuff with compactness and metric spaces. Hey, what's up, Jack Mack? No, this is the study sessions. So for a long time, I've been a daily live streamer, or at least weekdays mostly, studying a variety of different math books. The Serge Lang series is a brand new series where every week I'll be posting 2 or 3 videos on that Lang textbook. But right now is calculus. Today, actually, you're joining the last day of the Farewell Calculus Tour. Farewell Calculus. Good riddance. I like calculus. It's not what I would study for fun. Like, I love calculus. If I have infinite time, I would keep studying calculus. But for the sake of getting a job or supporting the basic math series, I think it's going to be better to replace my college level math with either abstract algebra or number theory. So I really want to know what you all think, like Locke and Arad and like the other mathy people. Do you all think I should add in, like, for myself, studying and relearning number theory or abstract algebra? Which one would be better overall? Like, both of those sound fun to me, but for the sake of introducing like all these new people who are getting turned on to pure math, I kind of feel like abstract algebra. I want to share abstract algebra with a lot of people. And abstract algebra, I think, connects well with representation theory. No, I have not checked out the algebraic derivatives thing. It looked really cool. I skimmed it, but I haven't worked through it at all. But yeah, nice to meet you. I think Jack Mack, Serge Lang. That book is pre-calculus. Like, we're starting at the very beginning, but ooh, Yeah. Honestly, I don't see enough down to earth but also advanced number theory content on YouTube. Right? Like I'm thinking like you would vote number theory? Yeah, like I think like basics like Euler's totient function and stuff like that, which counts the number of relatively prime uh what is it? Phi n counts the number of wait. Yeah, counts the number of relatively prime integers less than or equal to n, right? There's some really cool number theory around this. Like, you can prove a lot of really cool stuff here. I think that it's multiplicative, if I remember correctly. For example, you can get Fermat's little theorem. You can prove with, and I think it relates to this totient function. Fermat's little theorem. Yeah, I mean it's tempting. I might do number theory. I have a first test on Monday, and you're in Calc 1 in the fall. Possibilities to touch some algebraic number theory. It's going to be a while. Yeah, eventually abstract algebra and number theory. I don't know, man. I feel like number theory is just it's kind of familiar. And I like the idea of introducing people to a new subject. Although number theory, most people haven't really ever studied and like number theory is not even required for a math degree. Like at least at my university and I think everywhere, number theory is still an elective that you can take or ignore. And I loved it. I took it and I loved it. But algebra is required. Like algebra, you cannot skip algebra. And like the most important number theory you can learn in algebra. Are you talking about Gaussian integers? Yeah, I mean that would come up if we did a number theory stream. We would. Primes are nice. Yeah, they're not ugly at all. Yeah, wow. So this is Euler's totient function. But either number theory or abstract algebra could be a good stream topic to show more proofs, like more intro to proofs. I think I want to do an intro to proofs series for my college level streams. Torch? Well, that's what we're here for. Maybe we could help you with that. They're fun, dude. They're fun. Maybe you just never learned it the right way. I don't know. You also fear number theory in a good way? Like you want to learn it with us? Like we could help you. You know, we could help you, y'all. Like it's nice stuff. It's really pretty. Okay, so now theorem, the intermediate value theorem. I didn't write down the number, but who cares? If f is continuous on a closed interval AB, then for any k strictly between f of A and f of B, there exists at least one I'm going to put it in parentheses, at least one C in the interior such that f of C equals K. Intermediate value theorem. Yeah. These two important consequences of continuity may seem obvious, but in fact they rely on a subtle mathematical property of the real numbers called the least upper bound axiom. These rely on an axiom the least upper bound these rely on a property of the real numbers. Properly explaining the proofs of these theorems is outside of the scope of this book. So this book does not explain the proofs of these, but it states them. Great. This book is not a real analysis book. Outside the scope of this book. In the extreme and intermediate value theorems, the hypothesis that f be continuous on a closed interval is essential. Closed interval is essential, and it gives some examples of functions where this has no minimum value. This function has there is no x value that takes the y value k. Like, the function never takes the value k in this one. The fact that it's continuous on this interval continuity on the closed interval is essential. This second function is not continuous on that interval. And then this last, no c with f of c equal k. So this one, the second fails the intermediate value theorem. This first one fails the extreme value theorem. And then the last function that they draw, I don't need to draw the axes, just the basic shape and idea of these functions is enough. This function is not continuous at that point C. It has no maximum value on this closed interval. It's not even defined at x equals c. Dang, you famous. I know, dude, it's crazy. Hey, Siraj. Yeah, bro. Bro, how's it going? You don't have to ask 1,000 times. It's because what I'm doing is valuable, dude. It's worth $1. I think it's worth $1. I am leaving up the last 5 or so of every series, so you can check out those. And if you want to go back and watch hundreds of previous live streams, it's set to the lowest value that YouTube lets me put it at. So, Um, Thanks, Leroy. Appreciate it, man. Am I a professor? No, I am a software engineer. I'm a math major turned software engineer, returning back to math, and I'm becoming a high school math teacher. Yeah. So I mean, I like the live streams are free. The live streams are really meant for those who are here live during the session. But I keep seeing in my analytics that people watch the streams, like the VODs, and then they unsubscribe. I'm getting a bunch of unsubscribes from people who watch the live streams because this is totally unstructured. It's not, like this is not organized. It's not a course. Like a lot of people keep thinking that the streams are the course, and I want to make that clear to people somehow. So I feel that putting them out there as a soft paywall is a good way for me to say like this is not the course. The course is the basic math videos. Hey, thanks, Mohammed. I appreciate the 100. Appreciate it, dude. Math whiz, retired software engineer, guitarist extraordinaire. I wish I were retired, man. I wish. If I could do this for a living, I would do this, man. Like I love math. I love classical guitar. I love streaming. All this is fun. Like if I could, that would be fantastic. But I also just want to teach kids. Like even if I weren't getting paid, like I feel if I had the chance, I want to just teach kids, dude. Is it not? I don't know. Yeah, somebody correct me. I thought it's Muhammad. Is that right? All right. Well, anyways, let's keep going. There's we just wrote down the intermediate value theorem and the extreme value theorem. And extreme value theorem. If this is in Stewart, like I bet it is in Stewart, but it's not tested on the AP exam. At least back in my day, they didn't test for this. I think I got 2 pennies. I think it was 2 joules. I think you just gave me 2 pennies. I appreciate it very much. Reinvent math, you won't. No, I'm not going to reinvent anything. I can reinvent streaming. There's too many video game streamers. We need more math streamers. Dude, I don't think I'm particularly special here. I'm not the best person at all at math. Like, I'm not even close to that. But, yeah, I think we can get some people to stop playing video games online and start studying math. we can get people to switch from TikTok and video games to math. I really think so. Okay, Theorem 119. These beautiful, tasty theorems. Yeah. A function can change sign only at roots and discontinuities. Cool. Precisely, it says a function f can change sign from positive to negative or vice versa at a point x equals c only if f of x is 0 . undefined or discontinuous. I mean, if it's undefined, isn't that captured by discontinuous? I don't know why they repeated this at x equals c. Like, only if the function value is 0 or discontinuous, I think, is enough. Like, if it's undefined, then it's discontinuous. The graph that follows at the left shows a function that is continuous on a to b and changes sign only at its roots. Graph at the right is discontinuous somewhere and therefore can change sign as we move left to right without ever crossing the y-axis. Yeah. Okay, so two examples of functions. The first function has a value here. It has a root here. It has another root here. And then another root here. Oops. Oh, we're getting Notability's trying to help me out here. I don't want that. Thank you, though. Okay. So in this case, this spot is A. This spot is C1, this x value is C2, this x value is C3, and then this x value is B. And F is continuous on the closed interval A to B, and it changes sign at each of those zeros. Like, anytime that the function changes sign, it must be 0, undefined, or discontinuous at that point. This next example, we have a function with a discontinuity and it changed sign even though the function value was not 0. Make math great again. Yeah. I don't like it when we make things great again, but we should make math great. Yeah. Reinvent math you won't. Of course not. Yeah, unify all of math. No, I can't do that. Math sucks? Why would you say that, dude? Math rocks, bro. Hey, Santhosh, thank you. Thank you. I'm glad that you're enjoying the basic math series. I'm very proud of it, and I'm looking forward to seeing where we go with it, because I think it's got a lot of potential. Clearly there's a lot of people out there who, are excited to be studying math for fun. I think math is awesome. Like, it can be a good hobby that's good for your brain and just fun. I definitely believe that. I'm on video games while on the stream. Come on, dude. Math can be your video game, dude. No, it doesn't disqualify you. No, bro, it sucks at some point always. Nah. I mean, there's different types of math. I don't really like analysis. If I'm going to be honest with you all, I don't love calculus. It's okay. Like I got decently good at it, but my favorite kind of math is more algebraic. I prefer the algebraic side of math. So, hey, Jack Mack, I mean, if you're enjoying this, I'd say hang out here and just get a vibe for what we're doing. Like, over the next week, I'm going to be studying some complicated math, some like graduate level stuff that you're not going to follow unless you're a math major. And that's okay. Like maybe you still just get a vibe. Maybe you just get a sense. And hopefully, some people, I know some people like to just study along with me. Like you study whatever it is that you're working on. And hopefully, some people can be productive, studying together. So I think yes, you can try. It works for some people, not for everybody though. Um, No, people, Suraj, if somebody's a channel member, their name is green. So right now, I don't think that we have any channel members at the moment in this chat. And that's fine. Like, dude, I do not want to be pressuring anybody. I'm not suggesting, there's no expectation in my mind that anybody signs up to be a channel member. Like, it's an honor to be able to hang out and practice math and share it for free with you all live. It's just I don't want like every single stupid day where I'm making random jokes to be permanently available forever and like analyzed and every dumb little arithmetic mistake that I've ever made. I don't know. I want like a little bit of privacy about my own mistakes and I don't know. Mean value theorem. We haven't hit mean value theorem yet. Bro, D. Martin. D. Martin, thank you, dude. If you're here, I appreciate you very much. Let me know. I would be happy. Yo, we got a hobbyist too. D. Martin. Bro, we got a new hobbyist in the chat. Thank you, dude. I think I owe a few new names, by the way. D. Martin. D. Martin SCA. Dude, thank you so much. No, I'm not done with the Lang book. We'll be doing it for a while. The great Yaya. Yeah, dude. Appreciate you all. Like, this makes me so happy and encouraged that there are a bunch of math nerds out there, who like what we're doing. So I'm going to write down a name every single time somebody super chats, like special people who have helped. Like Leo Lectures has not paid me a single dollar, but he's like a good friend of the channel and we've collaborated together. And, likewise with like Locke and Levi and Happy Abe and others, although Happy Abe just signed up. But yeah, this is the thanks page. It's kind of like Patreon walls, like YouTube creators will do that. I want to do the same thing. Okay. Yo, D. Martin, all right. Been enjoying the lesson so far. I've always loved math, and you love the idea of studying it as a hobby. Keep it up. Hell yeah, dude. Since you're here, is there a certain type of problem or math topic that you'd like me to work? Like for hobbyists, I will pause whatever I'm practicing, and I can work a problem that you want to see. So if you want, I could work something from the basic math book, or I could work a problem from calculus or something else. Dude, appreciate you very much. Thank you. And yeah, definitely check out the VOD of the members only live stream from a couple days ago. Dude, thank you. Least favorite math for more people. All good? You're just hanging out? All right, hell yeah, dude. Well, thanks. I'm still going to credit you then. I'm going to say that you are a sponsor of calculus today. Thank you, bro. D. Martin SCA. You are now permanently tattooed in the exercise set. You're now permanently tattooed in the exercise set for continuity, bro. Thank you, Luke. Huge and D. Martin. Thank you for supporting continuity. We're almost done with this problem 0. I'm almost done taking notes. I'm basically like a hot tub streamer. I'll write your names for $1. Function can only change signs at roots and discontinuities. Now we have a few examples. Examples, bunch of examples. I feel pretty good. I can skim these, but I think that... Oh, a real-world illustration of extreme invalid. Yeah. Yeah, I'm good on these examples. I'll pass on the examples. We did it! We did it! Hell yeah. Problem 0 complete. Lol. Yeah. Hope you don't mind me tattooing your name in my books. All right, next problem. 1.4 skills. We have a skills problem, and this one says, for each, describe the intervals on which f is continuous. Describe the intervals for which f is continuous. For each discontinuity, describe the type of discontinuity in any one-sided continuity. Justify your answers about discontinuities with limit statements. Okay. I'm just going to give a ... on that. I said it out loud. We have 1, 2, 3, 4 ticks on the y-axis, and we have 4 ticks, 1, 2, 3, 4 on the x-axis as well. We have a discontinuity at the point at x equals 2. The function value is 3. And then otherwise, it looks like we have a line going up with a steep slope here, and yeah, this book does not draw arrows on the graph, but it looks something like this, and I assume that the book means that this graph continues in both directions. Like other books will use like a little arrow sign on the graph itself. I think that this book is trying to say that this function f is continuous on negative infinity to positive 2 and positive 2 to infinity. So it is continuous on those intervals. These intervals do not have closed ends. So the function is continuous on those intervals. It is discontinuous at x equal 2, as the limit as x tends to 2 equals 1, which does not equal the function value at 2. The function value at 2 is 3. Oh, shoot. Limit as x tends to 2 of f of x is not equal to f of 2. So it is a removable discontinuity as patching or changing f with, if I change the function value to be 1, then this makes f continuous on its entire domain, which I assume this book is saying is the real numbers. Seems like it. Gain a lot more value out of this than a hot tub streamer, though. Yeah, I don't know, man. I mean, depends. Depends. For some people, you know. Some people I'm just saying some people might prefer to watch a hot tub streamer, and I'm okay with that. I understand. Is Thomas Calculus okay? I think it's okay. I like this book a lot better, though. This book is definitely a lot better, in my opinion, because it's more conceptual. This book is way more conceptual, I think, than Thomas. Yeah, no, the intuitive definition, if I come back to the intuitive definition that people often say, you'll see a lot of people say that a function is continuous if you can draw the graph without picking up your pencil. So this type of graph is the type of failure that the exercise is. It has a discontinuity. It has a different value somewhere than its limit value. So this is something called a removable discontinuity. But formally, like not the intuitive definition, you define continuity of a function at a point. The left limit equals the right limit equals the function value. And then you can define left continuous and right continuous as well. You define continuity on an interval. Yeah, and then you can classify discontinuities, some of the simple ones. So it's continuous on those intervals. It's left continuous, I suppose. Okay, yeah. Yeah, I think I got this. Describe the intervals for which it's continuous. I think I have enough here. I showed that the limit of f of x is 1 from either direction. The limit value is 1, but it doesn't equal the function value. And it's a removable discontinuity because you can change that one function value and then it fixes it. And then that fixes it. Yeah, we're done. That's it. It's number 23. I worked Stewart calculus, and I know Stewart and Thomas are really, really similar. They're very similar books. I've tutored out of Stewart a lot. That's a book that my university used for, for the standards calculus sequence. This book is newer, and I think it's really good. I think it's really good, actually. I really think Taalman is really nice. It's both conceptual and, it's got both conceptual and applied, calculational problems as well. I like Taalman. Applications. Speaking of applications, how are we on time? We're almost 2 hours in. I should probably wrap this up soon. So this will be the last problem. And then, farewell, good riddance, calculus. We'll end with an application problem as is appropriate for calculus. Applications. Explain in practice. Here, you know what? I'm not going to bother writing this whole thing. It's a lot of words. I like writing the problems when I can, but there's a lot of words in this one. So we are looking at an application of the extreme value theorem. Explain in practical terms what the extreme value theorem says about each continuous function. Then explain in practical terms what the intermediate value theorem says in each situation. So, solution. Alina hasn't cut her hair for 6 years. 6 years ago, her hair was just 2 inches long. Now her hair is 42 inches long. Let h of t be the function that describes the length in inches of Alina's hair t years after she stopped cutting it. Okay. H of t is defined on the interval on the closed interval AB equal 0 years since she stopped cutting it to today, which is 6 years after. By the extreme value theorem, there is for the minimum and maximum values of h, there is some point do they use m and capital M as the x value or the function values? I want to get the same notation. Oh yeah, okay. Let me fix this. Okay, so by the extreme value theorem, there are points lowercase m in AB and capital M in AB such that if we assume that hair grows monotonically, which means just strictly growing, then lowercase m is 0 and capital M is 6 years. With f of lowercase m equal 2 inches and f of capital M, the maximum value is 42 inches. That seems like a reasonable assumption. I don't think that hair grows and then shrinks and then grows again or anything like that. Yeah. Hey, Jorion, you came at the end. Yeah, I'm almost done for today. What's up? It's an album image from one of Wanglein's projects. Interesting. Kohn value theorem. Yeah, h of t should be monotonically increasing. Yes, it would be, I guess, yeah, monotonically increasing. Your textbook needs to define like strictly monoton. Does monotonically increasing mean strictly monotonically, or because often you say, oh wait, no. You say that if f of a is less than or equal to f of b for all a less than b, then often you call this function increasing, which sounds a little funny, but then if f of a is strictly less than f of b for all a less than b, then we call that, I think, monotonically increasing. If I remember correctly. That's the interval. H of 0 would be 2 and h of 6 would be 42. Did I get that wrong? Yeah. No, I got that. So, yeah. F, I forgot that we are using h. In other words, h of 0 is 2 and h of 6 is 42. That these are the extreme values. Do we have to sketch a graph or anything like that? I think hair growth is sublinear. I think that you would expect something like this or something for hair growth. So if this person had 2-inch long hair, maybe this is 2 inches and now this isn't drawn to scale, but this is now 42 inches, then your closed interval is from 0 to 6. Couldn't there be a hair limit where it practically stops growing? Yeah, I mean, that's a good question. That's why I'm saying, I think that hair will continue growing, but it will slow down. Yeah, I do think that it will slow down at some point. Y is greater than 0, of course. John's hair would be a parabola. Okay. Yeah, Y is... So I tried to draw that Y started at 2, right? If the function value starts at 2, then this would, I think, represent... I'm using an iPad with Notability. iPad, Notability, Apple Pencil, AirPlay, Air Server. OBS, all those things. All right, so now I think that explains what the extreme value theorem tells us about this continuous function. Practical terms, what does the intermediate value theorem say in each situation? By intermediate value theorem, there is some point, let's call it C, or x naught in A to B, let's reword this. By intermediate value theorem, for any hair length, let's call it L for length, in the function values from f0 to f6, I think it's a little bit, I shouldn't write it like this. I mean, that assumes that we know that it's monotonically increasing. But for any hair length between 2 and 42, there is some time t in 0 to 6 such that h of t equals L. For example, if, what's her name again? If Alina wants to cut her hair when it is exactly when it is 40 inches or 30 inches or something, there was some time, there is some number of years between 0 and 6 when she should have gotten a dang haircut. If she likes to cut her hair when it's 30 inches, there was some point of time when she officially became lazy and was overdue for a haircut. I think that's like a translation of what intermediate value theorem is saying. There was some point of time where she became overdue for a haircut if her preference was 30 inches. Centimeters are better than inches. According to you. I think that's pretty good. I think that counts. And I'm fairly tired. I think I'm done for today. We've gone for 2 hours working some calculus problems. I really had fun today, as always. Please do like and subscribe. And hey, if anybody wants to share the basic, if she cuts her hair at 30 inches, well, I'm saying that there was some time when it was 30 inches. That's That's what the intermediate value theorem says. It's not like her hair suddenly overnight went from looking good at 25 inches and then suddenly it became 42, right? It didn't just jump overnight and become too hairy. There was some point of time when she should have gotten a haircut, and now she's overdue for that. According to 95% of the planet, rather, this is the intermediate value theorem that we're talking about. The second check mark here. So let me bring up the definition again. If f is continuous on the interval for any function value between the two endpoints, there exists at least one point in the interior such that f takes that function value. So there exists some point if I take k to be 30, then there exists a time such that f of t equaled 30. There was a time when Alina had perfect hair, at like 30-inch perfect hair. Yeah, assuming that they grow continuously and they started at under, yes. Yeah, those are the assumptions in the problem. It says continuous function, assume that this is a continuous function, that hair growth is continuous. I think that's a reasonable assumption. Like, approximately. And that the problem tells us that h of 0 is 2 and h of 6 is 42. So there is some time when Alina had perfect hair. And she should have gotten some photos done or something. Like, if Alina's favorite hair length is 30 inches, then there is some point when she had perfect length hair. There exists some time between 0 and 6 years when she had perfect hair. Yeah. Yeah, and of course, if she cuts her hair, that's a discontinuity. That would be a jump discontinuity. The graph would probably look something like this, and then again like this, and then again This is the lifetime of haircuts. Speaking of, I should get a haircut. Something like this. Okay? And then, yeah, certainly on that day, she begins anew. These are all jump discontinuities. Okay. So my analogy that I was trying to make is that Alina wants to cut her hair when it is... I'm just adding some extra ideas as just one example of how you can describe what the intermediate value theorem says about this situation. For example, if Alina wants to cut her hair when it is 30 inches, there is some time t, but strictly greater than 0 and strictly less than 6, such that her hair length was 30, and so she should have cut it then. That's like the perfect hair length, maybe. Yeah, I can show the problem statement again right here. Oh yeah, we're starting to get to some Barber's paradox stuff here. Like, what if Alina cuts her own hair and she... I don't know, yeah. Barber's paradox. Yeah, exactly. That's what I'm trying to say. Or another saying that's probably more realistic is like her perfect hair length, her ideal hair length, like, that she loves is 30 inches, right? There was some day between 0 and 6 years when she had her favorite hair length. There was some time, there was some day that was like the ideal, perfect hair day. Yeah. The sentence is false. Tell me whether the sentence is true or not. Yeah, there's all sorts of... paradoxical stuff there. Awesome. Thank you, everybody. Well, thank you. I had a blast today. This W hair the days. That's why you got confused. Okay, you were claiming that at some point she had 30 inches of hair. Yes, well, that is true. Oh, you thought that she immediately cut it at 30. Oh, okay. No. The problem is saying that today her hair is 42 inches, and a long time ago her hair was 2 inches long, and she hasn't cut it between. So there was some day when her hair was exactly 30 inches, or 30.1 inches, or any number in between, if we assume this is a continuous function. Yeah. So there was some day when her hair was 30 inches long, is really the only thing you can say on this, and then I'm adding a little bit of extra imagination that's her favorite hair length or something. Yeah, W hair days. There was some W hair day within the last 6 years. Thanks everyone for watching. I had fun today. If anybody wants to share what I'm doing with anybody else, you can say this out loud. mathcanbefun.com. Oh wait, no, math can be a hobby. That's what I meant to say. mathcanbeahobby.com. Playlist for basic math videos. So if you ever want to share what I'm doing with folks, that can be like a really useful URL to share this with anybody. John's hair as a function has a negative derivative at t equal... Yeah, my hair is shrinking because I'm an unk. Dude, yeah, we're not even considering hair loss and things like that. Like, what? Ugh, dude. I'm getting old, bro. I'm getting old. I'm an unk, as the kids say. We didn't even have that word back in my day. All right. Thanks for watching, everybody. Please do like and subscribe. And if you know anybody who likes math, share it with them. It's, live streams become 10 times more fun, when you know people in the chat. So invite your friends and let's all just geek out about math together. Thanks. Appreciate you all. Take care. Bye. Bye.